forget some ions. Okay, now again, we have 0.2 moles of sodium hydroxide. So this is where you don't want to mess up this early. Okay, what sodium hydroxide, how many moles of sodium are in there? How many sodium atoms are in one molecule or one formula unit of sodium hydroxide?
One.
Just one. So if this is 0.2 molar, how many moles of sodium do we have? Or I'm sorry, if we have 0.2 moles of this, how many moles of sodium do we have? 0.2, not a trick. How many moles of hydroxide do we have? 0.2. Okay, same here. How many moles of magnesium do we have? 0.2. How many moles of chloride do we have? Nope. I heard someone say it. 0.4. Look at that closely and see if you can figure out how I did that. Remember, magnesium, if this is magnesium, let's draw two magnesium chloride formula units. Okay? If this is representing Mg, and here's our Cl2. Okay? All right. Let's assume we have 2 moles. And let's see, this is representing the 2 moles, okay? In 2 moles of this, how much magnesium do we have? How much red do we have? 2. 2, 2. In 2 moles of this, how much blue or chloride do we have? 1, 2, 3, 4. So notice we're paying attention to the subscript. It's not so much the coefficient. The coefficient tells you in which ratio they react. The subscript tells you exactly what that molecule or that formula unit looks like. Okay? So when magnesium chloride dissociates, 1 magnesium and 2 chlorides come out of there. Okay? So does everybody understand why it has said 4 moles? Okay. All right. So again, this is going to be our start. All right? Is there any ion that is going to go to 0? Let's see. Magnesium is in the precipitate, that's for sure. So definitely it's going to go down, but is it going to go down to 0? No, why not? It's not the limiting reactant. So some of it will go bye-bye or precipitate, but some will be left over. What is the ion that will go down to 0? The hydroxide, because it's limiting and it's in the precipitate. Everybody get that? Okay. So in terms of what is used up, let's start with our limiting. Let's start with that ion. That's a great place to start. So our hydroxide, we have 0.2 moles, and let's look. 0.2 moles is going to get totally used up. And if you look, 2 moles of hydroxide makes 1 mole of magnesium hydroxide, but each of that has 2 hydroxides in it, right? So even though it's going to make 0.1 mole of this, that contains 0.2 moles of the hydroxide. So this goes down to 0. Yes, Ethan?
So can you use an ionic equation like a molecular equation and figure out specifically which ions are limiting?
Yeah, you could. Okay, so everybody understands the 0 here. Okay, so the concentration of hydroxide is 0 molar. 0 moles over 0.2 liters, but we can just jump right to 0 molar. Let's look at the magnesium, okay? We already determined that's not going to go down to 0, right? Okay, so if 0.2 moles, let's look at the ratio. Every time 0.2 moles of hydroxide is used up, or every time 2 moles is used up, how much magnesium is it using up with it? Only 1. So if 0.2 mole is getting used up, how much of this will get used up? 0.1. Everybody get that? And we keep the numbers very simple because there's enough brain work going on in here, isn't there? Without having to worry about little teeny math. So we're going to actually have 0.1 mole used up, so therefore 0.1 mole left over. So this is the used up, and then this is what we end with. Okay? So now the concentration of magnesium ion is going to be 0.1 mole over, what did we say our volume would be if we mixed 100 and 100? It would be 200, which is 0.2 liters. So that would be, what's 1 divided by 2? 0.5. And so 0.1 over 0.2 is still 0.5. So we have 0.5 molar.